So let's try to see if we can visualize this data in a different way. So rather than using a box plot, we're going to do a violin plot. So with the same data set, I'm going to copy and paste the import matplotlib, and I'm going to import this data set into a new Jupyter notebook. And then we're going to apply something different to it. So we're going to still use matplotlib, but we're going to try to see what a box plot looks like. So we're going to create a new figure using this code here. And so we're going to create a subplot out of it. And then eventually, let's just run that, get it into there. So it just created this sort of frame for us. And now we need to tell it what data it's going to have. And so we're going to, and this is again from using AI. So I'm going to paste this in. So it's telling me to create a violin plot using the Y data. So what we've got defined up here is Y create a violin plot. So this already has all the code and calculations and everything needed to act on this Y data. So there's very little that we have to do. We just have to provide it the data set and tell it what we want. And when I first did this, I thought, oh, how interesting, uh, because we'll see what happens. And so it tells you what's going to happen here, but we still need to show the data. So we're going to show the data like this and see what happens. And that's it. We need to get it to act all together though. So I'm going to copy this. I'm going to paste it here. So I want it all essentially in one sort of go here like that. And I'm going to delete this and I'll delete this. And we'll run it again and see what happens. So if we do this, now we'll see we've actually got the data plotted in here. We've got an axis. But the one thing that's interesting is that it plotted this horizontally. It's normally, this looks like a distribution. So really it is a distribution of the data. And so along this axis here, we're seeing a distribution of the data. So if we have an average of this information here, the average or median potentially is in here. And if we wanted that, we would actually say on violin plot, we would put in a comma here and we would say equal medians equals true or something. I'll find out what that is in a second. But this is the distribution of the data. You can see it's distributed about here, and they do a symmetric sort of distribution here. This is plus or minus. So it's interesting. But normally box plots are kind of plotted in the vertical position. This is what you see like a histogram, or if you were to do a Gaussian distribution, that's what it looks like. So, but like I said, they mostly are plotted in a vertical position. To give you an example of that, this is a different library. This is called Seaborn. So we're currently using Matplotlib, which is the main one built into Jupyter. There is another one called Seaborn, and it's a pretty good one for visualization. It's one of the best that's out there, but it's not natively inherent to Jupyter Lite here on the web. And so there is ways that you can import this, but for some reason for my laptop, I could not do it. So for the life of me, I could not figure out how to import this library in without using the downloading Jupyter onto my PC and actually going from there, which works. It totally works. The other option is if we really want to use this, or if you want to use this, Google Colab has this built in. So you don't have to import it. Sorry, you'd still have to import it, but I mean, you don't have to put it natively onto your desktop in order for it to work. But just to give you an idea, so this is Seaborn, you can download, so it tells you how to download. But this is an idea of the output. So there's several different data sets here. And it even has its own sort of code for you're going to import Seaborn. You're still going to import matplotlib because it lives on top of the matplotlib. Tell you the type of grid. But there is pulling in your data set as a function, but instead of using pandas to do it, you're using Seaborn itself. So Seaborn is working on top of pandas, which I'm surprised we don't have to actually import it. But Seaborn is now loading the data set and it is creating the data frames that are required. It will create the variables for the data sets that are going to be done. It's going to get different levels. So the levels are if we were to have lab group A, lab group B, lab group C, those are levels. So get the level values. And then it's going to define the columns and then start to compute a matrix. And then it'll start plotting it. So pretty similar right there. That's with the matplotlib. That's what we were doing. It's doing the exact same thing. It's just doing it in a much fancier way. So using the Seaborn violin plot instead of the matplotlib violin plot, it's going to output it, and it's going to look a little bit fancier than ours. We can change the colors. We can change a variety of things. But what's interesting out of this is a distribution of the data. So we've got a huge amount of data here. When it comes out bulbous like this, there's a large amount of data that's in this, and very little data here. Very little data here. There's a a secondary sort of area here where there's a larger distribution. So if I had a normal distribution, none of these are normal distributions. You know what? This is closer to a normal distribution. So one big bulbous area like this, that's kind of more of a normal distribution of the data. But if I had two sort of distributions of the data like this, then we can start to visualize that and see all sorts of different types of things that are happening. So there's one set of data that occurs here, another one that occurs here, another one that occurs here. So we can see and visualize that kind of spread and the dispersion of the data much better. So back to this. I don't want this on the vertical axis, sorry, on the horizontal. So I'm just going to delete that. Let's try to run it again. Ta-da! And there's a box plot. That looks more like what we've got. All right, and the bottom and the top here essentially are, I believe they're max and min, or they might be the 25 and 75% quartiles we would normally see in a box plot. So if we compare this, there's our box plot. So there is where that median is there. There's our whiskers, and there is some outliers that are associated with it. Whereas the violin plot, it takes into account those outliers are part of this, but the majority of the data is skewed around this four point whatever it is, like that. And so we can't see that. We know there's a median here, half is above, half is below, but we don't actually see how much of the data, really how much of it is there. And that's why the violin plot says there is a lot of data around this area here. All right, so let's see how we can, something else I wanted to do. Yeah, put the median in. I can just, on the same thing here, I'm telling it to plot the Y values, but I can actually tell it to show medians, all one word, like that, and I can say true, like that. And if it comes up nice and green like that, that it says that it's active. And if we run this, we can see the median shows up here. I can change the color of it. Again, it's a little more complicated and whether I want to do that or not. And I can also put in the mean, so the average. So show means, it's with an S, and I'm going to say true to this. Let's see what happens. I haven't actually done this yet. So there's another one. So the problem is I don't know which one's which, and for this, the median is the one that we care most about. And there's another one here that says show extrema, and I'm curious what this does because I don't know. So why not play with it right now in front of you? Hopefully I spelled that right. And I don't see anything different out of it. So I'm not sure if there's anything different that happened there, but that was it. So again, there's a possibility that we can actually change the colors of the lines. You can put an outline outside here. You can make this really fancy, just like you can with Seaborn. But Seaborn has it built in, and it makes really nice looking graphs. I don't know if the calculations behind it are proper or not. The assumption here is that they are as well, but it's pretty good. So again, this shows the spread. So we want to apply this on a larger data set. So much like we did here with the box plot, and we want to apply it to a larger data set. So let's do the same thing. We want to apply this. We want to pull in more information. We want to create box plots, essentially, let's say of the average of these, or even just the 4 of the columns. And we want to plot them all on the same graph. So we'll do that in the next part. So here I've got the code loaded in already and an example of the box plot. And it's on a single column of data. So if we go here, this is P1 ASA. So we take a look. It's this data set right here that I've got highlighted. This is the one we're doing a box plot of. So just a single box plot. And we're going to call in pandas so we can deal with the data frame, the visualization using matplotlib. We're going to read in our file as a data frame. So you'll find this, use that one. And we're going to create a variable. The variable is going to be called filtered data. Now this one did not use the group by function. I did create another one that uses the group by function instead. But I just thought I'd show this one here. So there's a way to filter data if you want. So the entire data frame, I want to, based off of the column year, I only want the year 2017, and I want the lab day A. So that's all. That's all we're doing. So we're trying to get a box plot specifically for 2017 and for A. That's all I want. And so I'm getting a box plot of this data down to right here. So this is the last part. So all of this data here is going to be called in to this specifically. And so remove rows with any missing PSA values. So now that we've got that column defined, remove any missing values because apparently it can't handle that. So this one right here would cause a problem with it. This is on a different data set, but this one right here will cause a problem. So we need to remove that. And so now create the violin plot. So there it is, violin, and this would be our data set. So specifically we want the filtered data that we've got, and specifically this column here we're interested in. So we could change this column and we'll see this sort of be changed as well. And here I got show medians true, so I can actually see the median data. And we can see then that the plot labels, we put an X label here that says year 2017 and lab day, so that one data set was collected. And put a label here. This is really, this is RF values. We'll learn that about it in the lab, but this is the RF values for the TLC plates. And then we tell it to show the plot. And here it is. And we can see that there's a huge skew of data right here. And that would be the hope because we're doing pure ASA. We're trying to run it on the TLC plate. And the hope is we should see just majority of data right here. And we are seeing that a little bit up here, which is unfortunate, but a lot of it here, which is what we were kind of hoping for. And like we could do a box plot on this as well. I'm gonna say, but it would look like this, and it gives some visualization, but not a huge amount. So let's say we want to now compare multiple columns. So I want to compare quite a few columns instead of just one column, much like we did with the box plot. Well, we can go about doing that as well. So with this code, what we're doing is we're calling in two different columns. We're doing the P1 ASA and the P1 salicylic acid. So this is pure ASA and pure salicylic from plate one. So we've told pandas to import pandas to PD, import the visualization tool, read in box plot CSV as a data frame. Here we've got rid of the drop NAs right in the beginning, and remember this isn't as selective as if we were to do drop NA after we've defined the data that we want. So this one here is a little more extreme, and if we could, we'd prefer to use the drop NA down here where we're actually starting to pull out the data if we could, or do drop NA specifically on P1 ASA and P1 SA. So we'd rather do drop NA on that, but this is what we've got. So if I wanted to correct this in Copilot or ChatGPT, I would pull in this entire data set here, or code, sorry, and I would say drop NA on P1 ASA and P1 SA only, and it would redo the code here for me to get rid of this here and be more specific to these so we would see a better data set out of it. But anyway, this is what we got. And so we're going to create the violin plot. So same thing here. We're going to have our figure and axis. We're going to use the plot. So this creates the two, there's going to be two subplots that are going to be created out of this. Those are the boxes. And then within that, we're going to create the violin plot based on column P1 ASA, which had all of its null values dropped. And we're going to have then as well a violin plot here for P1 salicylic acid. So we got two separate plots, one on top of each other. That's great. However, we would like to see these all compared to each other. And so we have one last file to take a look at, or one last set of code. And note that this will change a little bit because when we're calling in multiple ones and trying to put them on the same plot, we want to make sure that we've got 4 columns worth of data to be able to pass through this violin plot function. So we're going to try to create 4 columns of data from the data frame and pass it through this. So let's see what they've told us to do, and you can see the outcome here. But now we're using NumPy. So there may be a way to do it without NumPy. Again, you could use Copilot to help you figure that out. But simply pandas comes in, matplotlib, NumPy as well. and we're going to read in the data frame. But hopefully you can see at this point that this is the outcome that I want, and I really don't want to spend a lot of time trying to figure out why it's not working when I can get ChatGPT or Copilot to do all the heavy lifting for me so I can visualize the data and just do what I want with it. Anyway, so it looks like specifically for 2017 is the year that we want. So we're creating a variable right here based off of the data frame. And out of the data frame, we want the year, specifically 2017. And we want the data frame to have the lab day A. So this is the same thing we did similar before. We're using year and lab day, but now we want forward or well, how many columns are we doing here? 1, 2, 3, 4, 5, 6, 7, 8. We're doing all the columns. Wow. So we're doing all the columns individually. So we've got the columns defined as this list here. So we've created a list with columns, and it looks like we're going to do a for loop. And so for each one of these columns, we're going to pass through the filtered data, essentially what we're going to do. And we're going to drop, oh, look at that. We're doing it specific for each one. This is slick. Thank you, ChatGPT. So this one here, rather than going through and doing drop NA up at the top here, it's doing it for each time we iterate. It's going to create a Violin box plot of filtered data for the column. So for column, call in columns. So this one here, we've got our defined list of columns. So it's going to pull in this one and say, right, 2017, I'm going to fit some data to you. I'm going to drop any null values, and then I'm going to plot you out. And so that would be that one. And I'm going to do it again for the next set. For this column, I'm going to apply the next data set to that one, and then to that one, and then to that one, and to that one, to that one. So here we've got the plot. I don't see anything that talks about the plot size, but this is where we could actually change things. So one, we could actually change the x-axis so that these were horizontal instead. Okay, it looks like what we have to do is when we do the set the X label as to columns, we have to rotate. So rotation vertical. So let's see if this works. And there we go. So we've rotated those vertically so they're easier to see. So that helps a lot. So right there. So again, I, I copied this whole code. I pasted it into Copilot and I said, make the X labels vertical. And this is the only thing that changed out of it. So I said modify the code so that this is vertical. Now I could have gone through and I could have gone to matplotlib and I could have figured out for set xtick labels and this vertical thing, and it would have taken a lot of my time just to get this going. And there's a much easier way of doing it now, and that is with AI. So, so there you go. So there is a much more advanced way of doing it. I will take a look and see if there's a way using group by, because that is definitely my preferred method, although this works. So you're creating, again, a list called columns. You're going to use a for loop on this list of columns, and you're going to take every subset of filtered data, apply it to the list columns, and assign data to it, and now spit it out here. So that's essentially what this is doing. For me, using the group by is a little more intuitive, and I'll see if I've got something later for you to take a look at.